Computed properties in C# are a powerful tool that enables us to calculate and retrieve values based on other properties. By combining the concept of computed properties with storage, we can create a cached evaluated property. For instance, we can enhance the full name property to perform a string interpolation only the first time it is accessed. Hello guys, welcome back. Before going any further, based on what we said in the previous lecture, in the player class, let's utilize the appropriate properties to combine the first and last names instead of directly using the field. By using properties, we can ensure that any internal logic or validation associated with the properties is applied throughout the class. Okay, let's continue. In this example, whenever we access the full name property, it calls the getAccessor for the first and last name properties and concatenates their return values. To optimize this, we can introduce a backing field associated with the computed property and store the calculate value in it. Okay. In the getAccessor, we'll check if the full name field is null. If it is, we'll store the result of this concatenation in the full name field. And then return it. By following this approach, the concatenation only occurs the first time the property is accessed. After that, the getAccessor directly returns the value stored in the full name field without any additional concatenation. To confirm this, let's print a message inside the if block. After that, let's duplicate this line several times and run the application. As you can see, the code inside the if block is executed only once. Alright, as you may have noticed, there is a bug in this implementation. If we update the value of either the first or last name property, the previously computed full name field remains unchanged. To confirm this, let's change the first name. As you can see, although we updated the first name, but the full name still remained unchanged. To address this issue, we need to modify the set accessors of the first and last name properties. Okay, whenever we change either the first or last name, let's set the full name field to null. This ensures that the full name property concatenates the first and last name when accessed again. Now let's run the application once more. As you can see, the concatenation only occurs the first time, and each time we update either the first or last name. This type of property, known as a cached evaluated property, stores the computed value of a property in a storage or backing field for efficient access. Cached evaluated properties are extremely useful when working with complex objects or performing repetitive calculations. They provide a practical solution for optimizing performance and reducing redundant computations, specifically in scenarios involving complex objects. Actually, in the team class, we have a property called total points, which is more complex compared to the full name. To improve performance, we can cache the calculated total points value in a backing field. Let's start by declaring a backing field or a storage associated with the total points property. Next, let's use an if statement to check if the total points value is 0, since the default value of numbers in C# is 0. Inside the if block, we perform the calculation and store the value in the backing field. Also, let's print a message indicating the total point is calculated. Finally, we return the result. On the other hand, we need to modify the set accessor of each property used in the calculation. In this case, in the set accessor of the wins and draws properties, we set the value of the total points field to 0. By doing this, the calculation of total points is only performed the first time and whenever we update the wins and draws properties. Alright, let's create an instance of the team class. And then set the wins to 14, losses to 5, and draws to 11. Then let's print the total points 3 times. After that, let's change the wins to 15. Also, let's print the total points 3 more times. After this message, let's set the losses to 6. Okay, as you can see, the calculation is only performed twice. In the first time and when we update one of the properties involved in the calculation. Additionally, as you may notice, after modifying the losses, the calculation doesn't happen, since it's not used in the calculation. Okay, done. See you in the next lecture.